So the next set of deductions that we're going to do here are for implication introduction, right? And this is a little trickier now because in order to deduce an implication, you need to go from an antecedent and show how that leads to the consequent, right? So if you assume the antecedent and you can derive the consequent, then you know that the implication holds. And so this is the general strategy for implication introduction. So there's two examples that Professor Ellis used on the Lightboard, and we're going to run through them both here inside of JAPE. Now the first one is we start with a couple of premises, P implies Q and Q implies R, and we want to be able to deduce P implies R. Now this isn't a forward approach, it's a backward one. We want to introduce this implication. And so under the backward menu, we have the introduction here of implication, and this makes an assumption for us. And so you'll see it fills in the assumption that it's trying to do automatically. And so if we assume P and we're able to deduce R, then we are able to deduce P implies R, right? And so since we can assume P and since we have P implies Q as a premise, we can apply the implication elimination in a forward way to now get Q. And similarly, since we have Q implies R as a premise and we now have Q inside of this box, as long as we keep it inside of there, we can use implication elimination and get R. Right, so we assumed P, and since we had as a premise P implies Q, it gets us Q. And now we have Q, and we have as a premise Q implies R, we can get R. And since just from assuming P, we can get R, we now know that P implies R. And so our deduction proof is complete. Right, and so just to show how this can work in a repeated setting, this is a valid sequence where there's no premises. We just want to be able to show that it's valid to state that P implies Q implies R, right? And so similar to the last one, implication introduction is a backwards type of reasoning. And so we're going to reason backwards here. And this means that if we assume P, then we can get Q implies P. And again, we're going to reason backwards to break this implication introduction to break it down again. So as a backward step, we do this here. And the proof is complete, right? This was just a very simple pair of steps that we had to do. It's a 5-step proof, but it's only 2 interactions with JAPE here. So again, for the implication introduction here, it assumes P and it gave us something to break down again. And here it assumes Q and it gave us something to break down again, right? And the reason why this assumption here, if we assume Q, then we get P, it essentially just copied P, this hypothesis 1, it copied it from step 1 of the proof. Because we assumed it in this outer box, we're allowed to access it in the inner box as well. It just sort of copies it down. And so this is the complete proof for the valid sequence that P implies Q implies P.